All right, we're going to combine sections 5.2 and 5.3 together because they fit beautifully, and you won't even know which is which, so don't worry about that at all. We are going to be talking about binomial probability distributions in this next section. And so let me give you again kind of that big picture from up on high viewpoint that hopefully by now you've gotten used to. All right, so binomial distributions are discrete random variables. So they are what we just talked about in the last section. Okay, they are discrete random variables with two characteristics. Okay, the first characteristic is each outcome can be viewed as a success or a failure. Okay, success and failure, win or loss, heads or tails, lives, dies, whatever. Okay, so we're going to just generically call it a success or a failure. And then number two, there are repeated independent trials. And remember, independent, back from chapter 4, independent trials means the outcome of one does not affect the next. Okay, so what happens in trial number 4 has nothing to do with trial number 5, has nothing to do with trial number 6, etc. So in example 1, what we're going to do is just using that definition up there of what makes something binomial, we're just going to look at some scenarios and figure out whether they are or are not examples of binomial experiments, okay? And if it's not, we're going to tell why. So a random sample of 30 cars in a used car lot is obtained and the mileage is recorded, okay? So we've got two things that have to be passed here. So number one, every outcome can be viewed as a success or a failure. Now read what the outcome is here. We are recording the mileage. So we're going to get 30,254, 126,972, 50,146. Are those things that you can qualify as a success or a failure? No. Okay? You cannot qualify those as success or a failure. Okay? So we do not have number 1 fails. Okay, number 1 up above fails. Okay, we don't have a success and a failure. We do have repeated independent trials. Okay, one used car, the mileage on that one has nothing to do with the one sitting next to it or across the lot. But in our success and failure guideline number, this one fails. All right, B. A poll of 1,200 voters is conducted in which the respondents are asked whether they believe Congress should reform Social Security. Okay, so is this binomial or not? So do we have an outcome that can be viewed as a success or a failure? Well, yeah, we do. They're not going to say success or failure, but their answer is going to be yes or no, right? Yes, they should reform it, or no, they should just leave it alone. So we fit number 1. And do we have repeated independent trials? Well, repeated, yes, because we sampled 1,200 people. And independent trials, well, when you call one person in Georgia and you ask them, and then the next phone call you make is in South Dakota, and the next one's in New Mexico, those are independent, okay? They don't know each other. They don't know who's being surveyed. And so, yes, we fit both number 1 and 2 from up above. All right, moving on to C. The names of 20 students in a class are put in a hat. The teacher draws out 3 names, one at a time, to figure out who will be the leader, the paper helper, and the snack helper for the day. Okay, binomial or not. So can we view an outcome as a success or a failure? Well, no, we have more than 2 categories there. We've got leader, we've got paper helper, we've got snack helper. That is not a success or a failure. Okay, so no, this is not binomial. Okay, number 1 fails to be held up. And then the other, are there repeated independent trials? So repeated, yes, but I want you to think about the independent part. Once a student's name has been drawn as the leader, their name isn't going back in the hat as the paper helper and the snack helper, right? They're going to pick 3 different kids. So we also don't have independent trials because the likelihood of your name getting picked changes every time a name gets drawn out of the hat. So number 1 fails, as does number 2. Okay, this isn't binomial in any way, shape, or form. And for D, a basketball player shoots 15 free throws. So binomial or not. Do we have a success and a failure? Yes. Success, he makes it. Failure, he misses. Do we have repeated independent trials? Yes, repeated. We've got 15. And independent, how you do on the first basket or first attempt has nothing to do with the second up to the 15th. Every time you shoot, you start back over again. Okay, so this one, yes, is binomial. All right, we're going to do just a little bit at the top of the next page real quick. We're going to give you some notation that will pop up. So this is the notation right here for something that's binomial, and I just want to give you like an explanation as to what all of those things are. So X is like what you're talking about, right? Rolling the dice, shooting the 15 free throws. That's your event or your outcome. The little tilde, the little squiggly line, means is distributed or is approximately. Okay, the capital B means binomial. Those are all fairly standard and straightforward, but we do need to definitely define the N and the P and the Q. And feel free to write down the X and the tilde and the B as well if you want to. The N is the total number of trials. So how many times you are doing something. Okay. P is the probability of success. And Q is the probability of failure. And I want you to just, again, make a note. The probability of failure will be 1 minus the probability of success, which is denoted P. Okay, because those two have to add up to 1 or 100% of the time.